Okay, so we are going to start talking about solving radical and rational equations. This is something that's super important and will follow you from here and through pre-cal and other courses. So it's good for us to know. All right, so if you can see this, we have, let me situate this a little bit. All right, so we have unit 6, rational and radical equations. So we're going from our square root functions, cube root functions, into solving those. So one thing, and we did this in class, is writing a rational exponent as a radical. So just remember that rational means fraction. So rational means fraction. And writing it as a radical, the denominator of your rational exponent is actually your root, or it's your index here. And the numerator of your rational exponent is actually your power. So this is your power and your index. And this x value under here is called your radicand. All right, so to solve a radical or rational equation, follow the algebra steps of inverse operations. So a rational exponent, the inverse of this rational exponent, x to the a over b power, equals x to the b over a. So if you notice, it's just the reciprocal of the fraction is the inverse. So raising it to that inverse power is would be the inverse operation. So steps to solving. Number 1, isolate the radical or rational. Use or rational exponent. Use the inverse. Solve for the variable, and then check for extraneous solutions. In this unit, we're going to have extraneous solutions, so we need to make sure that we label those solutions as extraneous. So here's our first example. This 1000 equals x to the 3/2 power. So if I notice, my first step is to isolate the radical or rational. So I want to isolate this. Well, it's already isolated, so now I'm going to go to step 2. Step 2 is use the inverse. So I'm going to raise both sides of my equation to the inverse power, to the 2/3 power. Okay, so I have 1000 to the 2/3 power equals x. So a couple of different things that you can do here. You can either plug it into your calculator, or we can solve it by hand. So I'm going to use my rational exponent to radical steps here, and I'm going to write it as the cubed root of 1000 squared. So the cubed root of 1000 squared. You can do this two ways. We can do the cubed root of 1000 and then square it, or we can square 1000 first and then take the cubed root. I like the first option because it leaves me with smaller numbers. So the cubed root of 1000 is what number multiplied it by itself 3 times gets me 1000 is 10. And then I'm going to square it. So my answer is 100. So I'm going to check now because I want to plug it in and I'm going to check it. So I'm going to say 1000 equals 10 to the 3/2 power. So that means if I write it as a radical, it is the square root. I don't really need the 2, but to the 10 to the 3rd. 10. I got 100 for x. I need to plug in 100. 100 to the 3rd. Sorry. So the square root of 100 to the 3rd. So we're going to do square root first, which is 10, and 10 to the 3rd is 1000. So we check out there. That's good. All right, let's go to another example. Number 2. Let's do this one. The 4th root of v minus 10. Let's make this x, only v, equals 3. All right, so I want to isolate my radical first, which we did, and I'm going to raise it to the inverse power. So the inverse of this, if you think about this, the 4th root of x minus 10 is the same as me writing x minus 10 to the 1/4 power. Okay, so raising it to the inverse would be the 4 over 1, or just 4th, right? So we have x minus 10 equals 3 to the 4th, which is 81. Add your 10 to the other side, and x equals 91. So let's see if this answer checks out. We have the fourth root of 91 minus 10 equals 3. 91 minus 10 is 81. And is the fourth root of 81 3? It sure is. So we check out. Some of these things you can do on the calculator, totally fine. Others you might want to do by hand just so you can practice it. All right, let's do the next one. Let's try, this is number 3. 735 equals 6 plus x plus 9 raised to the 3/2 power. So in this question, our rational exponent expression here is not isolated. So we need to move the 6 first before we do the other part. So this is going to be 729 equals x plus 9 to the 3/2 power. And so my next step, since I have it isolated, is going to raise it to the inverse exponent. So I'm going to raise everything, both sides, to the 2/3 power. So remember, this is the cubed root of 729 squared equals x plus 9. I don't know if I know the cubed root of 729, so I'm going to use my calculator here. So I can take this root first. So the cubed root of 729 is 9. That's nice. So cubed root of 729 is 9. So it's 9, and then I'm going to write it over here. 3729 squared. Cubed root of 729 is 9, and then squared is 81. Okay, so we have 81 equals x plus 9. Subtract 9. We have 72 equals x. All right, so that's what I get for my answer. I'm going to check for this extraneous solution. See if we have any here. 735 equals 6 plus 72 plus 9 to the 3/2 power. So I have 72 plus 9 is 81 to the 3/2 power. I can do this in my Desmos calculator here. So I have 81, and I'm going to raise it to the 3/2 power. Pretty nice, right? So it's 729. So 6 plus 729 equals 735. It benefits you to use your calculator here, so definitely use that to your advantage. 735 equals 735, and we check out. Nice job. All right, here is your try it question. Here is your try it question. It is 30 equals -2 plus 2x to the 5/3 power. So don't forget your steps, and we will go over the answer when we get back.